Hi friends, in this video we are going to discuss about the inductance calculation concept. So this inductance calculation concept is very important whenever we are going for the analysis of any electric circuit. Okay, so here the calculation of inductance means whenever the two inductors are connected in series or two inductors are connected in parallel, then how to find the equivalent inductance of the series connection and also the parallel connection of those particular inductances. So for that case we are going for the concept of inductance calculations. Okay, so basically in case of inductance calculations or in case of inductance calculation topic, so basically there are two different types of connections are there. So one is series connection and the second one is parallel connection. Okay, so series connection and parallel connection, these two are the different types of connections of inductances. So here the important thing is, if two inductors are connected in series, then how to find the equivalent inductance, or if two inductors are connected in parallel, then how to find the equivalent inductance. So these two are the questions we need to raise here. Now these two different types of connections we are going to discuss in this video, and also with the help of one problem we can get how to find the calculation of equivalent inductance. Okay, just see here the thing is, first we are going to discuss about the series connection. Okay, so series connection means simple. Here just see this diagram consisting of two inductors, one is L1 and the second one is L2. So if the inductors are connected like this type of connection we are calling as series connection. Okay, so whenever two inductors are connected in series like this, then if you want to find the equivalent inductance for this particular series connection, you can directly add the two inductance. Okay, like this. So just see here, L1 L2 both are connected in series, so that to find the equivalent inductance we can directly add the two values of inductance like this. Okay, so this is the solution we are getting if two inductors are connected in parallel, sorry, in series. Okay, so just see here, we are going to discuss about one problem here. Just see, this is the example 1. Calculate equivalent inductance for the following figure. Okay, for the following figure, just see this diagram. Okay, so here L1 L2 L3, three inductors are connected in series, and the value of L1 is 30 Henry, the value of L2 is 40 Henry, and the value of L3 is 20 Henry. Okay, so all these three inductors are connected in series. So we know that whenever we are going for the equivalent inductance for the series connection of any inductor, so we can directly add all the values directly like this. Just see here, so L equivalent is equal to L1 plus L2 plus L3. Now we know the value of L1 30 Henry, L2 40 Henry, L3 20 Henry. So by substituting these two values, so we are getting the value of 90 Henry. Okay, so like this we can easily find the value of total equivalent inductance for any series connection. Okay, so this is about the series connection of inductance and how to find the equivalent inductance for series connection. Now coming to the second type, that one is parallel connection. Okay, so now we are going to discuss about the parallel connection of inductors. Okay, so parallel connection means if inductor L1 and L2 both are connected like this. Okay, just see here, L1 and L2 both are connected in parallel, so this type of connection we are calling as parallel connection. Okay, So whenever the two inductors are connected in parallel like this, so to find the value of total equivalent inductance, so we can use or we can consider the reciprocal of individual inductor value. Okay, so that is the reason why. So just see here. So reciprocal of equivalent inductance is equal to the reciprocal of L1 plus the reciprocal of L2. Now 1 by L equivalent is equal to, by simplifying you are getting L1 L2 plus L1 divided by L1 into L2. Okay, so by simplifying this, so we are getting the value of L equivalent is equal to L1 into L2 divided by L1 plus L2. Okay, so like this we can easily find the parallel connection of any inductors connection. Okay, now based on this particular parallel connection of inductors, we can solve one problem here. Okay, so now the question is, calculate equivalent inductance for the following figure. Okay, now the given figure is like this. So L1 L2 both are connected parallel like this. Now our question is, find the equivalent inductance for this particular parallel connection of two inductors. Okay, so just now I told you, whenever we are going to find the equivalent inductance for the parallel combination, so we always choose or always consider the reciprocal of that particular value. So that is the reason why, so reciprocal of equivalent inductance, that is 1 divided by L equivalent is equal to reciprocal of L1 plus reciprocal of L2. Okay, so here 1 by 30 plus 1 by 70. Here the 30 is the value of L1, 70 is the value of L2. So that is the reason why I am directly substituting here. So the reciprocal of 30 plus the reciprocal of 70. Okay, so here by simplifying, just see here, so 1 by L equivalent is equal to 70 plus 30 divided by 30 into 70. Okay, now here, so 1 by L equivalent is equal to 70 plus 30 means 100 divided by 30 into 70 means 2100. Here double zero numerator denominator 0 double zero cancel, then you will get the value of, so 1 by, so here, so 1 by L equivalent is equal to 1 by 21. So that L equivalent is equal to 21 henries. Okay, so like this we can easily find the equivalent inductance for the series connection of inductors as well as parallel connection of inductors. Okay, so thank you so much for watching, and also please do subscribe my channel for more updates. Thank you.